Ex.14.2, it's a question number 4 is factorized. It's the first is a to the power 4 minus b to the power 4. So let's understand how to apply identity and which identity we need to apply in a particular question. Dear student, in this question you can find two terms are there. First term is a to the power 4. Second term is b to the power 4. Now first condition says let's confirm the first term is a square of something. Yes, it is a square of a square. What about the last term? That is second term. Second term is also a square of b square. Second thing we need to confirm between both of these square, is there minus sign? Yes. Is there minus sign? Yes, there is a minus sign between these two terms. So, my dear student, here we need to apply the third identity. Now, what is the third identity? What it says? Third identity says a square minus b square equal to a plus b and a minus b. One time plus, one time minus. It's not necessary that you should write plus in the beginning and then minus at the afterward. No, you are free to write minus here and plus here. No issue for that. This is our third identity. So my dear student, let's apply it in this. So this will be the square of something and this is also the square of something. So I need to mention here this is the square of a square and this is the square of b square. So next step, I need to say here a square minus b square and a square plus b. This is the first step solution. But dear student, if you observe again applying the same technique, first term is a perfect square of a, agree? Second term is a perfect square of b, agree? So in that case, what we have to do? We need to mention this way. First term square minus second term square. What about this term? This term remain as it is, a square plus b square. So let it be as it is. Don't touch it. Now, here you can see this is the square of a and this is the square of b. So, my dear student, next step, I need to mention that here a square minus b square. Again applying the same identity, third identity. Here both of these are the perfect square and between them we are finding minus sign. So dear student, the solution is a minus b, one time plus, one time minus, and here it is, this term is as it is untouched, a square plus b square. So this is the complete solution of the first of question number 4. These three are the factors of this expression. Got it? So here dear student, you can see a square whole square b square whole square. After applying third identity here, a minus b, a plus b. A is the first term, b is the second term. So one time minus, one time plus. But here student, according to the rules, again I am telling you this is minus and both of these terms are also perfect square. And this a square is a perfect square of a and b square is a perfect square of b. So I need to write here a square minus b whole square. And this is already here. So let it be as it is. What about these two results? Of course, we know a square minus b square, that gives the result one time minus, one time plus. That is a minus b, a plus b and a square plus b square. They are the factors of this given expression. Okay. So second is on your screen, dear student. We are given p to the power 4 minus 81. Now, how to apply identity? Which identity we have to apply? That how to decide? As usual, I told you first to confirm this first term is a perfect square of whose? We know this p is 4p to the power 4. So it is a perfect square of p square. This is the perfect square of p square minus. What about 81? Of course, it is a square of 9 because 9 ja 81. So, dear student, as usual, we know third identity we are applying. So, p square minus 9 and p square plus 9. Okay, p square minus 9, p square plus 9. Both of the sides should be have on they must be similar, only minus plus are there. Okay, now what we have to do, again you can see both of this is a perfect square and this is a perfect square of whose? Minus this is also perfect square of something, and here outside the bracket p square plus 1 is already here. Now what about this first term, that is p square is a perfect square of p, agree? 9 is a perfect square of 3. 3 3 ja 9. And with minus sign only we are having this result. So I need to mention here one time minus p minus 3 and one time plus, that is p plus 3. After applying third identity over here. So p minus 3, p plus 3. One time minus, one time plus, and this is extra. This is an additional term. So I'm mentioning p square plus 1. So this is a complete solution of question number 2. So my dear student, here question 4, it's the third is on your screen, that is x to the power 4 minus y plus z to the power 4. In such a case, how to simplify? To make our work easier, I am assuming. So let's take or assuming. Let's take y plus z, these two terms equal to m. Y plus z we are considering m. So our our expression will become x to the power 4 minus this is m to the power 4. X to the power 4 minus m to the power 4. Nothing I did. Only in place of y plus z, I substitute the value, that is m to the power 4. That is m. So next step will be x to the power 4 is already there. So I need to mention here because we are mentioning here square of square. Fourth power is square of square. So this is m square and whole square. This is also m square and that is whole square. So dear student, the answer is x square minus m square in one of the bracket, in another bracket x square plus m square. So this is not a complete solution because as we have assumed in place of m, you can see in place of m I assume y plus z. Okay, so I need to put this value of y plus z equal to 4 in this equation. So what do we have? So the next step will be careful, x square minus, what is m here? Y plus z. So let me write y plus z whole square. What is y plus z whole square? And here also, there are two options of doing this also. We can write in place of, if we do not want to write this keep it separate, and for this also write it in another way, that is x minus m, x plus m. So better I am writing here according to that. Our work will become easy. So this x square plus m is already there. Now in bracket this is x square minus m whole square. It indicates that x minus m and x plus m. And this is x square plus m. Okay, this term untouched, only for these two terms I have written one time minus and one time plus. Let's simplify. This is the This is the solution. These are the factors, but we need to substitute the value of m again here to get the perfect answer. So let's work out upon that. Any doubt? So my dear student, finally we got this much answer. Now substituting the value. Okay, substituting the value of m. This is m in given expression. Okay, in the expression. So dear student, here is x minus m is there. What we have assumed for m, it means y plus z. So let me write it here, y plus z in bracket. Okay, to avoid this minus sign, changes of this minus sign, try to avoid bracket. Try to avoid, you must mention it in a bracket. Now here x plus m. So next will be x plus in bracket y plus z. This is another step. And third we are given is x plus m whole square. So this remains same. X plus m whole square, x plus m square, only square. I am correcting, sorry, it's my mistake. This is x plus m square, not a whole square. Okay. Now let's simplify. This is quite easy. So my dear student, here also I need to put the value y plus z, and which is in a bracket. So I am writing y plus z whole square. Okay, because we are substituting the value of m all the way here. So let's open the bracket, x minus y plus z. Here in this, x plus y plus z. In another bracket, what to do with this? You can see here, x is already there. So in such a case, what should I do? Here it is x plus, how to move with this, y plus z whole square, that is y square plus 2yz plus z square. Okay. So let's open the bracket and we'll have the similar easy answer. If we open the bracket, then we will have x minus y plus z. In another bracket, x plus y plus z. And this side in a bracket, x is already outside, and I need to mention here y square plus 2yz plus z square. Right? So this is the complete solution. Nothing I did, only and only I substitute the value of 1. So my dear student, here I have written here, because according to the identity, whatever we have written in the last step, x minus y plus z in bracket and x plus y plus z in bracket, it indicates that here it is minus sign, x minus y. Yes, here I need to change the sign. I am correcting, this will be minus. Because of this minus sign I am changing, so it will be minus. Now for the plus, opening the bracket for plus, no issue. Okay, and for this x plus y whole square is there. What it indicates, how to work out upon that? So we know that the value of y plus z whole square, it indicates that we need to mention here x minus y plus z and x plus y plus z in another bracket, and in third bracket x plus y square plus 2yz plus z square. This is actually the second identity. Sorry, first identity we are applying here. Okay, after applying the identity, we will have this much of simplification. Now same procedure we are going to apply in next question.
Fourth is on your screen, dear student. X to the power 4 minus x minus z to the power 4. Now, let's assume x minus z that is equal to m. So we will have x to the power 4 minus m to the power 4. So dear student, we will have x square whole to the square minus m square whole square. So according to a third identity, we will have x square minus m square and x square plus m square. But dear student, again we need to apply the third identity here. So the factors of x square minus m square will be x to the whole square minus m whole square. So the factors are x minus m and x plus m. And already we had x square plus m square with us. So finally three factors with us are x minus m, x plus m and x square plus m square. Now let's substitute the value of m in each of these factors.
Now we are going to substitute the value of m. Okay. Here. So dear students, the next step, I need to write x minus. Now what is m? For m we have assumed x minus z. So let me write it in a bracket. X minus z. This is the value of m. Got it? Now x plus m. For that I am writing in another bracket x plus. Now in place of m, the same thing x minus z, I am writing it in a bracket. This bracket over. Now x square, here it is, plus what about m square? M square is x minus z, which we have mentioned. This is whole square of this. This is x square, got it? And in place of m square, I have written x minus z whole square. So dear student, it's too easy to solve. And for the third, we need to apply the identity. So let's work out upon that. So what we have to do in the next step, here you can see after opening the bracket here x minus x plus z, and this is x plus x minus z. Got it? In another bracket, here x square is already there. In place of x minus z whole square, this we need to apply second identity. Okay, it says that x square minus 2xz plus z square. This is the simplification. The second identity we are using here for this x minus z is x square minus 2xz plus z square. So you can see here plus x minus x cancel. So what is left? Here only z will be left. So let me write z here. In another bracket, x plus x is 2x. Agree? And this minus z. So it is 2x minus z. What about this x square plus x square? That is 2x square minus 2xz and plus z square. This is the complete solution of fourth part of the question number 4. Here you can see we have applied the third identity two times and this second identity one time while expanding this bracket. Okay. So question 4, it's a 15 on your screen, dear student. It says a to the power 4 minus 2a square b square plus b to the power 4. So in that case, what we have to do? In that, we need to apply the second identity here. Reason behind that, this is a square minus 2ab plus b square. Now this is the identity. But what is a here? Now dear student, here as we are given, the first term is a to the power 4. And we know that a to the power 4 is a perfect square of a square. Agree? This is also perfect square of a square. So here b to the power 4 is a perfect square of b square. So same thing I need to write it here, b square. So next step, I need to say that this is a square first term minus last term, that is b square, and this is whole square. So answer is a square minus b square whole square. Now for a while, forget this square. Square is not given. Here we have applied second identity. Now for a while, forget this square is not there and simply we are given a square minus b square. So how to sort out? How to solve this? In such a case, we need to apply third identity over here. So it says that a square minus b square, and dear student, the whole square is already there, so I am writing it as it is. Now what is the first term? First term is a here, second term is b. So as usual, third identity if we apply, then we need to write here a plus b and a minus b, and it's a whole square is already there. So this whole square indicate that square of this also, a plus b whole square, and it indicate that it is a square of a minus b also. So this is the complete solution of fifth part of question number 4. So dear student, exercise 14.2, it's a question 5. It's a based on middle term splitting method, which is quite new for you. The question is factorize the following expressions. But how to recognize that we need to apply middle term splitting method? Middle term, how to justify? First, you can see here this expression is having so, what you have to do here, just look at your screen, p square plus 6p plus 8. How to justify? Here you can see three terms are there. First term, second term and this third term. Now first question, ask yourself, is first term is a perfect square? Yes, it is a square of p. Is last term a perfect square? No, 8 is not a perfect square, because if it is 4, then it is perfect square of 2. If we are given 16, then it is perfect square of 4. But 8 is not a perfect square. So in such a case, how to simplify or how to factorize? So my dear student, this method is known as middle term splitting method. For that, whatever this number we are here given, let's write it here and get the factors of 8, such a factor that their product should give the product of this and their sum should give this result 6. So dear student, 8 is having factors 4 to ja 8. We know that the sum of plus 4 and plus 2, that gives the result middle term, that is plus 6. So my dear student, here we need to write the next step is p square plus 4p plus 2p plus 8. What I have done, again I am explaining, look at your screen. This is 4, one of the factor. So I split this 6p in a 4p plus 2p. I split this middle term with this 2, 4p plus 2p. So let me make a pair now. Now it is quite easy to solve. From first two terms we need to take out p as a common. So we will have here p left inside and 1 4 will be left. Out of this p, 1p is outside, so 1p will be left and this plus 4. From this two term, 2 is common, so here p plus, what about 8? 2 is already outside. When we divide 8 by 2, then it gives the result 4. You can see all the way both of these terms similar. So I need to mention p plus 4 in one bracket. In another bracket it is p plus 2. So these two are the factors of the given expression. P plus 4 and p plus 2, that gives these are the factors of the given expression. So my dear student, here I taught you how to apply middle term splitting method. Let's try to understand better the same thing or same method by applying it in a second expression. So second we are given expression is q square minus 10q plus 21. Dear student, here the variable q is given. So nothing to worry about. It's not necessary every time we will have X or a Y. We can have any English alphabet, small letters as a variable. So here we are having three terms. Q square is first term, minus 10Q middle term and 21 last term. So dear student, here 21 I have only. So I am in a middle term splitting technique. I need to have the factors of 21. Such a factors so that their sum should be sum of the same sign addition. Their sum should be minus 10. So dear student, first of all I know the factors of 21. 7 3 ja 21. Agree? The product of these two factors gives the result 21. And along with that, minus 7 minus 3 gives the result minus 10. Same sign, addition. So we need to write here q square minus 7q minus 3q plus 21. You can see here minus 10q I split in these two terms. Minus 7q one term and minus 3q another term. Now for further clarification or for a further steps, I am going to make a pair of these two. So from first two I am taking out q as a common. So one q will be left and this 7 will be left inside the bracket. From these two terms I am taking 3 common. So I will have here q, and because of this plus I need to write here minus sign. Sign will be changed, so it will be 7 3 ja 21. So equal to q minus 7. Q minus 7 I am writing it in a one bracket. In another bracket q minus 3 I am mentioning. So my dear student, the two factors of the given expression are q minus 7 and q minus 3. Let's try to understand better the same method with the third expression. So my dear student, here third we are given is p square plus 6p minus 16. These three terms are there along with the p variable. So let me have the factors of 16. Such a factor so that their sum, addition or a subtraction should be 6. So dear student, two factors I know, that is 8 2 ja 16. Fine. The sum of both of this is, now if I add that 8 plus 2 to 10, not possible. But if I subtract 8 minus 2, then it gives the result 6. So in such a case, I need to mention this is plus and this will be minus. So p square plus 8p minus 2p minus 16. Here I have mentioned plus 8p minus 2p. Now let me make a pair. From first two pair p is common, so p plus 8 is left. From these two terms 2 is common, so again p plus 8 is left. Because of this minus sign, here it will be plus 8 2 ja 16. So in one bracket I need to write p plus 8. In another bracket, that is p minus 2. So dear student, p plus 8, p minus 2, these are two factors of the given expression. Here we are applying middle term splitting method, which is quite new for you. And here the completion of exercise 14.2. Please students, practice it again and again. This exercise is very important for understanding purpose. Thank you. God bless you.